So for those who don't know, I'd like to introduce Dan Hill. Dan, VK4DNO. I know you've got 2 call signs, I think, haven't you? We're just going to put you, if you want to share screen and go up to, we'll put you on. We're watching you on the big screen, the TV, and streaming it out live and recording this, if that's okay.
Sensational. We love that.
Okay, over to you.
All right. I think this will be. Sure, you can all see that.
Yes.
Awesome. Thank you, Kevin, for having me and the wider Brisbane VHF group. It's a real pleasure to get in front of some clubs and to talk about things that are happening at Icom. And when Kevin came to me at the VK Summit to ask me to do this, he was quite happy about the presentation I did at VK Summit, which was the design philosophy for our flagship model, the IC905, and was wondering if I could potentially do one for the IC905 as it's a popular product with your particular group. So I thought I'd do that. And I'm not an expert. You guys have probably more lived and hands-on experience with the IC905 than I do. So you may ask me questions that will stump me, but I'm always happy to take things on advice. And happy to get back to you on those questions later on down the track with some of our colleagues over in HQ who actually designed the thing. So I'll get started. We're going to cover a couple of topics today. Firstly, a little bit about me. I'm an ex-broadcast person. I used to be on the radio many, many years ago. I was music director for one of the major networks across Australia. I was a television cameraman once upon a time, and even now I still do a little bit of radio on the weekends, just as a bit of a side hustle to keep my my skills intact. But also on top of that as well, I'm quite a technical person. So while I never worked in the engineering department with the radio stations, I always had a technical inkling and always found myself in the chief engineer's office and workshop to play around with all the toys that they had in there. So hence my interest in amateur radio began. Really got taken by the Parks on the Air and VKFF bug and loved getting out portable. Mostly on HF, not too much on VHF, UHF, or SHF. So certainly more things to do once I sort of upgrade my license, because I'm only standard at the moment. But certainly it can play around a little bit in that space. And yeah, with access to the 905, I think, I've got some nice toys to play with, as you would agree. So my role at Icom is all about advocacy and outreach, is to advocate and promote the hobby of amateur radio in VK and around the world, to have a fresh new face for Icom, and to create initiatives and opportunities for community engagement, to promote the history of Icom and its continuing involvement and active development of amateur radio products. Because as you know, Icom started in 1964 with Mr. Inouye, and some of his first products were particularly for amateur radio, and that legacy still lives on with Mr. Inouye today. He's aged 94 or 95. He's just stepped down as the chairman of Icom, so passing of the baton, so to speak. Other parts of my job, a lot of business development, so working with authorized resellers on current and new products. That also includes commercial products. It's not just amateur. It's everything from aviation to marine to land mobile radio to satellite radio to LTE to network products. Basically cover the wide gamut of product lines at Icom in my role. Also relationship building with clubs, associations and the societies, customer service and support. If you ever call the Icom office number, you'll more than likely get either Tanya or myself, because I'm based in the Melbourne office. It's it's quite handy for me to be on the phones and helping Tanya out, because Tanya's just an office person and she doesn't really get a lot of the technical jargon, so she hands those ones over to me, which is lots of fun. And boring sales stuff, obviously hitting budgets and targets and things. So the last 2 years, we celebrated our 60th anniversary at Icom. It's a tradition in Japanese companies to try and get to 100 years. Icom is well and truly wanting to become a 100-year-old company. It's a tradition in Japan that they take very, very seriously. So we're well on our way for that. It all started in 1964 with the Inui's Electric Company, with some amateur radios that he was building. They moved to their first headquarters in 1970. And as you'll see in a lot of these photos, on top of these buildings are really, really elaborate amateur radio antenna systems. It's no different to our office in Clayton. We've got a nice log periodic and a variety of other antennas on the roof as well, including a folded dipole, a couple of verticals and discones and all the rest of it. A new headquarters was in 1970, the bigger one. And then in 1974, started going global. So in 76, I opened Icom Europe in, I believe it was in Germany. Icom America started in 1979. They're in Kirkland in Seattle now. And Icom Australia started in 1982 in Melbourne. And our present day premises is this fetching black and red building on Garden Road in Clayton. Growth expanded in 1984 through to 1993. The Hirano factory was built in 1986 with a really lovely antenna system on the roof there. The factory was established in Wakayama, a small village in the Wakayama prefecture of Japan. And Nara, which is not too far away from Osaka, our R&D office was established in 1994. And the present day, our new Osaka building was opened in the year 2000. They're in the process of building a brand new one. The Kinokawa plant, which was also in Wakayama, a second plant in that prefecture as well. And in 2019, they opened the Wakayama Icom robotic line. So most of our products either are fully automatic or automated on the robotic line. Some are pick and place on the robotic line and then finished by hand. But the robotic line has been very instrumental in the growth of Icom's products over the last little while. A lot of people, if you've seen any of my talks before, you would have seen this video before, but I really like to show it because it shows a little bit of what Wakayama is all about, but also what our factory in that prefecture is like.
She's not holding the hot soldering. Did you say that? Yeah, I got.
All of Icom's radios are designed and built in Japan. We really are very proud of that fact, and we sing it from the rooftops whenever we can, that built-in Japan quality. And as you can see, some very enthusiastic people putting those products together from the Wakayama Icom factory. And then also it gets dispatched out of there and comes on from those pallets you saw them pulling out of the factory. They basically get loaded onto a Singapore Airlines jet and fly onto Melbourne Airport, where they're unloaded by toll and delivered to us in Clayton, and then off to dealers and other partners as well, including our friends over in New Zealand. So Icom Australia looks after New Zealand as well. So that's a bit about where Icom's at the moment, and more about right now what we're talking about is the development philosophy and commitment of the IC905. There was a really great document released about a year and a half ago, which was the design and development philosophy, which was put together by one of the engineers at Icom, who was very instrumental in the IC905 project. And I guess I want to sort of throw it out to the room as a little bit of a Q&A. Why VHF, UHF, and SHF? I think it's one of those questions a lot of amateur radio people don't tend to head up that far. They stop at 70 SEMS and away they go. So I guess my first question to the group, just to get a vibe of what gets you guys going with VHF, UHF, and microwave operations. So what draws you to participate in it?
just a challenge.
It's more of a challenge.
Yeah.
Yeah, I agree. I've been licensed for over 50 years now. I've tried most of the other stuff, and so I'm always looking for something that's just a bit more difficult and a bit harder to do, and keep the flame alive.
And you don't need 5 acres for an antenna.
That's true.
Yeah, the benefits of stuff that high in frequency is the antennas tend to be a lot smaller, although the arrays can be quite sizable too, though.
So
A lot less noise.
Yeah, absolutely. Your most memorable contact that you guys have made on SHF? Anyone want to share?
Well, yeah, I remember we actually managed to work from the Bunya Mountains in Queensland right across to New Zealand on 3.4 gigs. That's still an Australian record. It's only been done once, and we did it, and I'm pretty proud of that. That was a very special moment.
Was that up at the repeater site at the Bunya Mountains?
Yes, it was. It was
yeah.
the day before one of the field day contests, and just by pure chance, we were all up there anyway, and we managed to work Steve Heyman, now sadly Silent Key, and since then it's been done on 10 gigs between Australia and New Zealand, but this was the first time. It was the highest at the time frequency being used to go offshore. Basically, there was anything other than EME.
Incredible. That's awesome. Third question for you. What's the biggest challenge or barrier stopping more amateurs from getting into the world of microwave, do you think?
Cost.
Well, the perception of cost,
Perception of cost. Yeah.
Yep.
Sorry. Yeah.
Yeah.
Thank you, Peter.
because the 906 is not very expensive.
Well, no, it's not. No.
Compared to other.
Well, a bit of tongue in cheek, actually, Dan. We'll give you a bit of a background on that project after you're done.
Yeah, no stress. All good. So as you know, there's misconceptions about the SHF band, but SHF has unlimited possibilities, and I think amateurs of all ages and creeds should be able to enjoy the world of this band just as much as any other. And as you said, cost is quite a tricky thing for that barrier too. So I guess the 905 was designed with simplicity and ease of use in mind, but also cost was a factor in that design. So the 905 wasn't created because amateurs wanted another VHF radio. It was designed because Icom believed SHF was an underdeveloped part of the amateur radio band that deserved a modern integrated platform. And as you might know, a majority of amateur activity today is concentrated below 430 megahertz. So SHF remains a niche. I don't know, that's a bit of a typo. It remains a niche offering with unique propagation modes. Icom wanted to lower that barrier of entry. And it might be the cost is a factor, but also technical know-how is also a factor. Icom certainly put together something that's relatively easy to put together and use. But it was also developed because there was a need or a want after the IC Sat100 satellite radio project, where I'll talk a little bit more about the Sat100 project. But Icom already had a little bit of RF knowledge and technology required for microwave frequencies. So as part of the team on the Sat100 project, also worked on the 905. So they're very much into that SHF thing. And Icom's 905 mantra is aim higher. So the design background, it's kind of a mixture of three different areas for Icom. There's three images there on the screen. One is the IC Sat100 on the left there. The one on the top right is a marine radar, and then a network switch, which just looks like any other switch, but you'll notice there's an Icom logo on it. Talk about those in a sec, but I wanted to talk about the design background of the IC Sat100. So in around 2019 and 2020, Icom partnered with satellite network provider Iridium to develop and release the IC Sat100. It's Icom's first commercial professional radio that was designed to communicate through a satellite constellation. Now, I know we all use satellite repeaters or repeaters on satellites and the ISS and all of that, but this was designed specifically with Iridium in mind, which had its own unique challenges. The radio accesses the Iridium network, which is on the SHF band, specifically 1616 megahertz to 1625.5 megahertz. It provides coverage anywhere on the planet. currently being used by various government agencies who had a requirement for push-to-talk over satellite. It's not a sat phone, it's push-to-talk over satellite. And as well as our friends down at the Australian Antarctic program on the continent, they're using that when they can't get their traditional LMR repeater networks and DMR networks. Its development triggered a call from within the company for the creation of something fun and exciting that would pave the way for the future of amateur radio. So that project alone said, oh, hang on, we need to start working in these band spaces and provide a product in that environment. So Icom Japan focused their attention on the SHF band, an area that had not been explored by many amateur radio manufacturers, including Icom at the time. Marine radar was another element of this. In 2022, Icom released an updated line of marine radars, primarily for use in commercial vessels in Europe and the US markets. We didn't really see this product here in Australia. It uses a frequency slice of 9410 megahertz plus or minus 30 megahertz. Got a peak output power of 6 kilowatts with a maximum range of 72 nautical miles. It's got ARPA, which is the automatic radar plotting aid, and it also integrates AIS, which is carried over VHF. It also further flexed the engineering and design for SHF products for real-world use with Icom. The third thing we saw on that first slide with the 3 photos was network devices. Now, there's a bunch of products here on the right-hand side you may never have seen before. Why has Icom got an IP camera? Why does Icom have a LAN bridge? Why does Icom make phones? Why does Icom have a PoE switch? Well, for the Japanese domestic market, Icom's been developing these products in the ICT space for a couple of reasons. So these products cover everything from network switches, access points, bridges, IP phone systems, wireless IP cameras, and it's all in an effort to further study these technologies to implement them into commercial products down the line. So while we may not see these in Australia or America or Europe, definitely they're very prevalent in the JDM market. So some of the design goals for the IC905, I've put 5 of them down here, which is inherited technologies, a la borrowing things from other radios, operational modes, controller and operating systems, addressing coax losses at SHF, with a little side quest about separation and the all-important frequency stability. So at Inherited Technologies, direct sampling processing makes this possible. So since the launch of our IC7300 way back over 11 years ago now, the RF direct sampling method was used, and it's become a standard for all of Icom's all-mode equipment. So it was no surprise that the newly developed IC905 uses this same RF direct sampling method. So like the IC9700, the 905's RF sampling method operates in the 2 meter and 70 centimeter bands. RF signals in the 1.2 gig band and above are down converted to around about 351 megahertz before the IF sampling processing. And for those interested, there's a block diagram of how the direct sampling processing is put together in a very simplistic way. FM is probably the most common mode used on VHF, UHF, and SHF bands, although DMR and P25 and all sorts of digital modes are starting to be used a lot more often. I guess when this was made, I guess FM was still the be-all, end-all. So Icom wanted to design the IC905 as an all-mode radio to provide various options for operation and to encourage further experimentation of these modes in higher frequency environments, because as you know, you're trying to do SSB on 10 gigs quite tricky because you need to have that very accurate clock. We'll talk more about that soon. But since the radio is designed to be in VHF and UHF band radio, Icom decided to cover 1.2, 2.4, 5.6 gigs, in addition to adding SSB, CW, RIDI, AM, and FM, as well as D-Stars, digital voice, digital data, and analog TV modes too. It truly is an all-mode radio. The controller and operating system and the controller of the IC905 is almost identical to the IC705 with a couple of differences with the I/O and the way the back half of it's sort of put together. The interface on the side, as you would know, was revised from the IC705. On the right-hand side, there's the connector for connection to the RF unit, plus digital interfaces such as USB LAN and an SD card. And on the left-hand side, there's some analog interfaces, so speaker mics, external speakers, audio-video input for analog TV, and just a small diagram there of how that's laid out. For those who have a 905, you'll know this very, very well. So in addition to all these functions, the IC905 controller has another important role, which is to supply DC power to the RF unit, which is separate from the remote control head. So even when using the optional controller cable, which is up to 50 meters long, the 13.8 volts needed for the controller, supplied by the controller, sorry, is boosted to approximately 56 volts before being supplied to the RF unit in order to minimize losses. So the controller contains many power-consuming devices such as display backlights, audio power amplifiers, DC-DC converters for the power supply, voltage boosting, and a ton of other power supply circuits. These devices generate heat, so a heat sink was needed. Fins were installed on the back to dissipate that heat, and a small diagram of how that looks. And of course, how you operate the machine is just as important as its physical form. And so it was without question that Icom would incorporate the adored Icom interface, which is found on all modern Icom transceivers. So this familiar menu layout, waterfall, touch interface, and user experience help to make users feel right at home. And a couple of diagrams there of image transmission in DV mode on D-Star and SSB on 5.7 gigs. Coax loss is a huge deal, as you guys are well versed in experimentation of this. In the SHF band, there's plenty of circuit design issues, but there's an unavoidable operational one, which is the transmission loss you get on coax cables connecting the radio and the antenna. So as we know, the higher the frequency, the greater the loss of the RF signal over lesser coax cables. So we try to keep them short. It's common to use thicker cables where the loss is less in the operation of 2 and 70 centimeters. But when you get up to those higher frequencies, the loss becomes even greater. And the Japan Amateur Radio League did a study, and according to their data, a low loss type coax known as 10D-FB at 2300 megahertz is a loss of 1.95 dB by 10 meters. So based on this alone, if the coax cable is, the loss due to coax cable is 3.9 dB when the antenna is connected to the radio with 20 meters of that coax. So that means if 2 watt of power was transmitted into the antenna, only about 0.8 watts of output is at the antenna feed point. So, and although the data has not been published, if it was the 5.6 gigahertz band, under the same conditions, the loss would be even higher. So how do we fix it? So the idea was inspired by antenna-mounted type preamplifiers, typically used for receive. The antenna-mounted type preamplifier is a low-noise amplifier inserted directly under the antenna. So in the same way, you can put a linear amplifier with 2 watts of output directly under the antenna to compensate for the loss in coax cable and feed power to the antenna. So with the RF unit mounted at the antenna, transmit and receive signals at their maximum efficiency as the coax feed line is measured in inches or centimeters rather than feet. It keeps signal losses to a minimum. So this is really only possible due to the controller cable providing digital communications between the controller and RF units. And this is achieved by implementing, it's not exactly standard PoE technology, but it's using similar protocols. They're calling it PoE++, but it's not compatible with other PoE++ technologies, unfortunately. So separation of the controller and RF deck isn't new to Icom. It's one of Icom's strange idiosyncrasies, because if we look back in time, in 1977, Icom had an optional remote controller for the IC710, which was at the time quite revolutionary. 10 years later, there was a mobile rig that employed fiber optic cable for separation, which I don't know how robust that would have been back in the day, but they did it, and it still exists. There's working examples in this country of this particular radio, the IC900. 10 years passed and the IC706 comes out, which is the first HF rig with a separated configuration. Now, while I understand it's not putting the RF deck at the antenna, it's still talking about this sort of separation thought and theory. It continues on today with our current range of products, including the IC7100, the IC2730A, and the ID5200. Many of these Icom products follow through with this tradition of separating the RF deck and the controller, including our IC7760, which is designed to have the RF deck somewhere in an RF quiet place, and you can control that radio from literally anywhere in the world. Frequency stability is another big issue at those frequencies too. The RF signal is generally generated directly at the target frequency by a phase lock loop or a D to A converter. This is because of a reference clock frequency, which is the source of the frequency, is stable. An error of 0.5 ppm to 10 megahertz is 5 hertz, which is not a huge problem on HF frequencies. But when you get up there in those gigahertz range, the error becomes quite large. So using 0.5 ppm, the error becomes 640 hertz. So SSB at that error rate can't be demodulated correctly. When it comes to CW, the received signal may be outside the filter and can't be received. So even if a temperature control crystal oscillator is used, which is said to have a relatively high accuracy, is used as a reference oscillator, its accuracy is, if its accuracy is 0.5 ppm, the same frequency fluctuation will occur. So at 5700 megahertz, this would be as high as 2850 hertz, making SSB virtually unusable. So the solution to this is to use an oven-controlled crystal oscillator, which is also used in our last flagship radio, the IC7850 and IC7851. With this method, the frequency stability can be suppressed to 0.05 ppm. So this method can also be used to drastically reduce the frequency error to 0.05 ppm. On the right-hand side is the size differences between the oven-controlled crystal oscillator between the 7800 and the IC905, so it's quite small. But even with this method, strictly speaking, the oscillation frequency will gradually change due to changes in temperature and aging and a couple of other factors. It's not easy to prepare a reference signal for frequency calibration, so another clock source would be required if you're to use this oscillator with SHF. And so because the IC905 supports D-Star and because the D-Star, the radio is D-Star compatible, it's also got the ability to send and receive location information using GPS, because D-Star radios all have GPS receivers built into them to use this function. So automatically you've got a GPS module in the radio, which will capture pulse waves at 1 PPS. And this will give you a very accurate time signal, which is fired from GPS satellites. On the 905 there, you'll see the GPS constellation information on the left-hand side, and on the right-hand side, and a demo of D-Star on 10 gig, which is pretty interesting. So by utilizing highly accurate pulse waves, a highly accurate 10 megahertz reference signal can be generated inside the radio. So in other words, the built-in GPS oscillator or GPS disciplined oscillator compares and manages this with 1 PPS signal and the oscillation signal of the oven control crystal oscillator in the FPGA to further improve the accuracy and stability of the 10 megahertz reference signal. So by improving the accuracy and stability of the 10 meg reference signal, high accuracy and high stability can be ensured, even in the 5.7 gig band. This 10 megahertz reference signal is also used as a reference signal for our 10 gig transverter, and a small block diagram of how the GPS antenna integrates with the FPGA and the oscillators to create the 10 megahertz reference. Deployment to the higher SHF band. So when the IC905 was first developed, it was designed as a transceiver covering 5 bands from 144 megahertz to 5.6 gigs. After Icom announced the Icom SHF project on its website, there was a strong demand from SHF band enthusiasts. So we also began designing a CX10 transverter to cover the 10 gigahertz band. The transverter generates a signal of the target frequency by mixing 2 signals. To obtain a 10 gigahertz signal, 2 signals are required: an IF signal supplied by the IC905 and a local oscillator signal generated in the CX10G. For the IF signal, 2.4 gigs was chosen in consideration of the spurious signal that is generated when it's mixed with the local oscillator signal and the frequency range that can be output from the IC905. So when a transverter is connected and operated, the operating frequency must normally be calculated from the frequency displayed on the radio outputting the IF signal. But in the case of the IC905 and the CX10G set, the 905 recognizes the connection of the CX10G and it displays the operating frequency in the 10 gigahertz band as it is without recognizing that a transverter is connected and in operation. So essentially, it's kind of like an expansion pack for your IC905 without any other bits and pieces required. So similarly, the internal circuitry automatically switches the local oscillator signal frequency even in the wide bandwidth range of 10 gigahertz. So this makes it possible to scan multiple bands at once from the 144 megahertz band to the 10 gigahertz band and enables seamless operation as if it was a single transceiver. The connection between our CX10G transverter and the IC905 consists of only 3 cables. One is a control cable that doubles as a power cable. One's a coax cable for each of the IF signals and the 10 megahertz reference signal. These 3 cables connect the transverter to the RF unit of the IC905 mounted on the antenna mast, so no long cables are required. The CX10G transverter, like the RF unit on the IC905, is mounted on the mast directly below the antenna using a special bracket. And when using the optional parabolic dish, the 10 gigahertz band antenna, that connects to the bracket of the parabolic antenna to the bracket of the CX10, and it uses a semi-rigid cable supply with the antenna to minimize those losses between the transverter and antenna. And I'll get the question, and I don't have a good answer for you. What about 24 gigahertz? So if the IC905 is used as the main unit, transverters in other bands can be connected simply by modifying software related to transverter control. So for this reason, Icom's been focusing on communications in the 24 gigahertz band following the 10 gigahertz release of the CX10G. So far, there's just been tested prototypes of what I'm calling the CX24G. I don't know if that's actually what it's going to be called. Still very much in prototype phase. We were lucky enough a couple of years ago, you might remember Hero, who worked with us here at Icom Australia, who's now at Icom America, managed to get a demo of it working at the Ballarat Hamfest. But no information yet whether this is going to be a thing or not. Hopefully we'll find out some more information at the Tokyo Ham Fair at the end of August. So I guess for me, that's just a really quick snapshot of the design and development of the IC905. It's a really remarkable product. And I wish I could spend more time with it so I can personally understand it. But I know you guys have been using it quite considerably, which is awesome to hear. Before I take some questions and generally open the room up for discussion, I just want to show with you what's in the pipeline at Icom as well, because I think that's quite important. So as you'll know, the ID 5200A has been officially announced, which is awesome. So we're due to see these in August, September of this year. It's our new 270 centimeter dual band mobile radio with D-Star, FM only in D-Star. No SSB on this one, unfortunately. That might be in the next one. You never know. I won't go through all the specs, but that one's due to hit our shores in the next couple of months or so. And the next one there is the X026, which a lot of people have been saying it's going to be the 7100 replacement. Who knows? We'll find out in about a month's time when Tokyo Ham Fair's on. Icom Japan tend to love putting things on at Tokyo and love releasing a product or multiple products. I'd love to know what you think the radio should be or what it should have as well. With that, I'll throw it open to a Q&A and just general discussion.
Well, thank you, Dan, for a superb presentation tonight. Just to let you know that we've got, as you know, we've got 5 or 6 905s in the hands of our members. We've got one member who actually owns 3. And is using them fairly extensively. We've tried them on FM TV, ATV on 1296 and 5.7 gigs with great success, given demonstrations of that. We've tried the D-Star on 10 gigs over several hundred kilometers and had good results with that. Unlike in Japan, of course, we extensively use SSB, probably more than our Japanese equivalents do. And the devices have proved satisfactory for that. And in using digital modes as well, using Q65 in particular, and our own beacon chain that we run here runs JT4, and they detect those, of course, without any other sort of interfaces, just plugging straight into the digital port on the 905, and extremely sensitive on receive over great distances. So we're all extremely impressed, those of us who've got one. There's been a bit of a push. Some guys have extended the activity of the system so they can add in more preamplification and more power amplification. Graham 2SRC has a mobile system with 2 905s built into a trailer, and all with their own computers on each band. So he's simultaneously monitoring just about all the bands, digital and audio, all in one go. And he's running up to the several hundred watt level on some bands. We found a way around getting the 3.4 gig band, which is not included in the system internationally. We found a way of grafting in transverters using the 70 centimeter port, for example, to drive those through interfaces and diplexers. So we still have access to 70 centimeters and 3.4 gigs as well. And it's quite a remarkable piece of equipment. That's enough from me, I think, enough of my voice. What does everybody else think that's been using them?
I love mine.
Just Dan will know about the system that you've got. Tell Dan about the system that you've got with your
well, Dan,
automated dish.
Yeah, okay. We mount my 905 onto a repurposed VSAT trailer with a 1.8 metre AVL Technologies dish on. So we were able to work Graham at Vista Point. It was a distance of 320 kilometres on 10 gigs with just a barefoot 905 with the half a watt.
Incredible.
Yeah, and yeah, we just used the 3.4 gig transverter with a triplexer. So we still have 23, 2, and we used the 70 meg IF on 3.4, and all into a single multiband feed on the 1.8 metre dish. And the beauty of using the 905 is the fact that we could just sit in a tent 15 metres away from the trailer and the radio and just sit there and just change bands without having to do anything else. It's a fantastic bit of kit. We love using it.
I know there's been, when I saw everyone at QTech, I spoke to Graham as well. I think he had some suggestions about ATV on 70 SEMS as well. We fed that information back to Icom HQ and they were very receptive of that. And Kevin, I know you sent me an email this week just to try and figure out a way to help funnel some of that feedback into HQ as well. And I'm more than happy to be the conduit for that. I may even set up a dedicated email address for it just to keep it organized. But if HQ don't hear this feedback of features that you would like or upgrades that you would like to see in firmware or other, hardware support elements, I'm more than happy to share them with HQ. I've got a pretty good dialogue with them going now, and they're very receptive.
Oh, that's great to hear. I mean, the 70 centimeter issue is not that we want to transmit FM TV on 70 centimeters. We don't have the bandwidth for that available to us. But it's really for if we use it through a transverter so that we can send video across on 3.4 gigs in particular, or on 10 gigs if it's through a different system. I must admit, in my case, I watched some YouTube videos before I bought mine, and it was the ability to just do ATV in such a simple and effective way that pushed me over the line to open the wallet and buy one. That was the final push. And when you do it and you actually give a demonstration of it, Peter and I did it at a conference that we spoke at Redcliffe, in fact, 2 years ago. We set up quite a short distance display, but projected the output in video onto big screen TVs, and I think it pretty much mesmerized the audience. So it was they hadn't seen anything quite like that done before, and it was so easy and satisfactory to do.
And Graham went and bought two.
And then Graham went out and bought two.
Yeah, he loves his 905s. Every time I see him, he's like, I think I might buy another one. Which is always fun. And so for you guys, what are we oh, sorry. Yes.
Do you have any comment about the use of, or the eventual inclusion of the 10 meg reference signal in the 905, whereas everyone was disappointed with a lot of people were disappointed with the 9700, which was efficient in that area. Any comment?
I don't know if there's anything you could do with current IC 9700s. There may be stuff they can do in firmware. I'm not entirely sure. But I would assume that the 907 at some point in the near future, and I'm talking maybe in a year or two, will get the Mark II treatment, where it'll be a revision of what's currently out there, with the inclusion of other wanted features. So I would suggest that any issues that we're having with the 9700 at the moment will be addressed in whatever this Mark II revision will be. I can only assume that's going to be the case, just based off what treatment was done with the with the IC 7300.
Thanks.
Nothing else.
I guess mostly from my own interest, what do you guys got planned coming up? Are we going for any other world records? Or I know you guys, especially the Brisbane group, are very active in the microwave activity days. When I used to live in Brisbane, I used to see everyone up on Mount Cootha from time to time when I drive up there and wonder what these crazy people are doing. This is before I had my license, by the way. Probably drove past looking at you quite weird. But the more and more I get into this, the more and more interested I am in it. So I'm more interested to know what you guys as a club I've got planned coming up.
Well, we run those microwave activity days on a regular basis through the year, and because it promotes activity. There's a few of us here, Doug, myself, and a few of the others who particularly enjoy operating portable out from high spots. It combines all the good things in life, really, radio and a bit of outdoor activity from a high spot and the peace and quiet. We're always trying to push back the boundaries, get that little bit further. The ability to use both SSP and digital with high stability gear and a bit of power, the combination of a bit of power and digital modes has opened new doors that weren't even there before. And the chance to run things like aircraft scatter. We've worked many hundreds of kilometres on aircraft scatter, for example, between Brisbane and Rockhampton on 5.7 gigs, and from Bundaberg down to Brisbane on 10 gigs on SSP and digital. It's all opening new doors. The 905, of course, is perfectly placed to do this if we can just get around the power issue or the ability to drive amplifiers easily and successfully. That's probably where a little bit of development could improve the ability to do that. If only for the interfacing with press to talk lines. And then there are simple solutions that we found a way around, but the next generation could make it easier, and it's something that would be good to discuss with you and the engineers back in Japan.
Yeah, absolutely. I'm sure if they're not looking at it yet, they will be looking at it at some point. But no, I wanted to say thank you just for allowing me to share my thoughts in researching this this presentation. It was I will share the slide deck, but also the source material, which it is available online, but I'll just share it so everyone's got a copy of it. Kevin, I'll just email it through to you if you want to distribute it through the club. That'll be great, because it is a lot more technical, this document, than it completely over my head for most of it. So if you're really techie and you really want to know the ins and outs of circuit design and all that sort of stuff, it's all in there. You may or not have already read it, but I just pulled out the bits that I understood and I thought would be interesting for a presentation. So I hope it's been somewhat beneficial, and I'd love to come back and do it again at some point in the future.
Well, thank you, Dan. On behalf of everybody, both those of us who are here in the club rooms and those that are watching this being streamed out live, and also those who will subsequently watch this on our YouTube library, I'd like to thank you for giving the time up to talk to us tonight, presenting this talk, and I'll ask everybody to thank you in the traditional way. Thank you, Dan.
Thanks, guys. And if any of you are going to the Tokyo Ham Fair, I will be in attendance as well. So if you're in there, I'll look forward to seeing you in Tokyo.
See you there.
Okay, good night now. Thank you from Brisbane.
Bye from Melbourne, 73.